Okay, so today I'm going to be doing question number 93 from chapter 2, section 2. It's a 5-part problem. So, part A, um, use the position function s of t equals negative 16t squared plus initial velocity times time plus initial position for free falling objects. A silver dollar is dropped from the top of a building that is 1362 feet tall. A. Determine the position and velocity functions for the coin. So since they gave you the position formula, all you have to do is basically just plug it in. And since it's dropped from the top of a building, you're given the initial height, but the initial velocity is 0. So this part right there should equal 0. So here's my work. There's the equation. I plugged it in, and I got s of t equals negative 16 t squared plus 1362. And because the first derivative of a position formula equals the velocity formula, I took the derivative of the function, and I got v of t equals negative 32t because I just brought down the 2 here, so negative 16 times 2, and then I reduced t squared by a power of 1, so t. Okay. Alright, so part B. Determine the average velocity in the intervals 1, 2. Well, when you're determining average velocity, you just find the secant line between the two endpoints on the position formula graph. So you would just take the slope of that line. So basically just plug in 1 into negative 16t plus 1362, and then you get the y value of that position, and then you plug in 2 again, and then you get the y value of that position, and then you plug those values into the slope formula, and you'd get the average velocity. So here's my work for that. So when I plugged in 2, I got 1298, and then when I plugged in 1, I got 1346. And the final answer is negative 48 feet per second. Okay. Part C, find the instantaneous velocities when t equals 1 and t equals 2. When you're doing instantaneous velocity, it's at that instant. So normally you would take the slope of the tangent line of that point on the position graph, but since the tangent line is the first derivative, we can just, we already derived the function into the velocity and time graph, we can just plug it into that equation and then get the instantaneous velocities. So when I did that, this is my work, so the equation was negative 32t, and I plugged in 1 and 2, and for the 1 I got negative 32 feet per second, and for 2 seconds I got negative 64 feet per second. Okay. Okay, so parts D and E. So part D, it says find the time required for the coin to reach ground level. If you're going to reach ground level and you started at a height of 1362 feet, then the ground is going to be 0 feet. So in the position formula for S of t, you're going to plug in 0 and you're going to solve for t. So this is my work. So I plugged in 0 here. I subtracted 1362, so I got negative 1362 equals negative 16t squared, and I took the square root of both sides. So t equals exactly the square root of 681 divided by 8, or approximately 9.23 seconds. So part E says find the velocity of the coin at impact. So basically you take the time from part D and then you plug it into the velocity and time equation for part E because it's at impact, so it's at that instant. So my work for part E is right here. I used the velocity and time equation, and you don't want to plug in the approximated value because you would also get the exact answer for the velocity will be wrong, and so you want to plug in the square root of 681 divided by 8 right here. And once you do, after you plug in the exact value into your calculator, you can then round the answer to 2 or 3 decimal places. I did 2. So V of t equals negative 295.24 feet per second. Don't forget units.